Welcome to Get Your FRQ On. This question is from 2012. It's question 1, and it is calculator active. In the question stem, we have a table of values for the temperature of water in a tub. We're given that the function that represents the temperature of the water in the tub is strictly increasing and is twice differentiable. In part A of the question, we are asked to estimate the value of the derivative of W of t at t equals 12 to show our computations, give the units, and explain the meaning. So based on the table, the value t equals 12 is halfway between t equals 9 and t equals 15, so we can use the average rate of change formula to calculate the rate of change at t equals 12. So W prime of 12 is going to be approximately W of 15 minus W of 9 over 15 minus 9, which is 67.9 minus 61.8 all over 6, which is 6.1 over 6. So that's the actual value of W prime of t. And what this means is at t equals 12, the temperature of the water in the tub is increasing at a rate of 6.1 divided by 6 degrees Fahrenheit per minute. Notice we do have to explain ourselves since the question does ask for both units and meaning. In part B of the question, we are asked to evaluate the definite integral from 0 to 20 of W prime t dt, give the units, and explain the meaning. So we don't really know much about W prime of t, but this is a definite integral. We don't actually need to know much about W prime of t. Really, we just need to know the fundamental theorem of calculus. If I want to integrate a derivative function, that's just going to be the antiderivative of that, which would be our normal W function in this case. Evaluate it at the endpoints, 20 and 0, and then find the difference. So the definite integral we are after here would just be W of 20 minus W of 0, and those are values we get straight from the table. W of 20 is 71 degrees, W of 0 is 55 degrees, so if I subtract that I get 16 degrees. All right, so what does that mean? Basically, all this is really telling us is the difference between the temperature of the water after 20 minutes compared to what it was at the beginning. So this value just means that over that 20-minute period from t equals 0 to t equals 20 minutes, the temperature of the water in the tub went up 16 degrees Fahrenheit. In part C, we are asked to use a left-hand Riemann sum to approximate 1/20th of the definite integral from 0 to 20 of Wt dt, and then explain whether this is an over or an underestimate with a justification. All right, so using a left-hand Riemann sum, we can just take the values right from the table. We get left endpoints and the widths of the intervals. So 1/20th of the integral from 0 to 20 of Wt dt would be 1/20th of this sum of products. From 0 to 4, that's a width of 4, so we're going to take the left-hand endpoint, that's 4 times W of 0, plus 5 times W of 4 for the next interval, plus 6 times W of 9 for the next interval, plus 5 times W of 15 for the last interval. This is a calculator active question. We can substitute the values for W of 0, W of 4, W of 9, and W of 15 directly from the table since those are given to us. And since this is a calculator active question, if you needed to use a calculator to simplify this, you can have your calculator do it for you. Yeah, there's decimals in it, but it's a calculator question, so who cares? Just have your calculator do it. And it turns out that 1/20th of that sum is 60.79. All right, so is that an overestimate or an underestimate? Now, we're given in the question stem that this function is increasing, which means our left-hand endpoint is always going to be lower than our right-hand endpoint. So the rectangle we use to approximate an interval like that will always be an underestimate of the actual area, and if that's true for all of our rectangles, it must be the case that our approximation using the left-hand Riemann sum would also be an underestimate. Right? Why is it an underestimate? we're given that W of t is strictly increasing. In part D of this question, we are considering the interval from t equals 20 minutes to t equals 25 minutes, and we are given a function w prime of t that describes the rate at which the temperature of the water in the tub is increasing. Notice that this doesn't contradict what's in the table. The table only goes up to 20, and now we're talking about what happens after that. So there's no overlap here. This is a completely separate function, and we want to use the information to get the temperature at t equals 25. We're given in the table the temperature of the water at W of 20, and to find the net change from there to 25, net change is going to be a definite integral. So we're going to take our ending value from the table, which was W of 20, that's 71 degrees, and we're going to add that to the definite integral from 20 to 25 of this new function, w prime of t equals 0.4 square root of t times cosine of 0.06t. But this is a calculator active question. Again, you're going to use your calculator to evaluate the definite integral. And when you do that, w of 25 would be 71 plus the value of that definite integral, and on a calculator you get 73.043 degrees Fahrenheit.